Okay, as part of yesterday's lab, we need to label our periodic table. So if you would take a second and take your periodic tables out, we are going to label the kind of half side, not the full side. So find the one that looks exactly like this. And then what we're going to label, you can see them on the screen already, but up in the key area, CWA means cold water and acid. So what CWA is, so right here, that means everything in family 1 will react with cold water and acid. Now, if it reacts with cold water, it will also react with hot water. So really, family 1 will react with everything. All right, then moving over to family 2, we have HWA. HWA means hot water and acid. So I'm not going to write it, but it's everything the same after this as here. So what that means, and we learned this in the lab yesterday, that magnesium did not react with cold water, but it would start to barely react with hot water. Beryllium, since it's above magnesium, would have similar properties to it. But then as we went lower, calcium, you'll remember, did react with cold water and acid, and anything below it would as well. Now, if you don't want to write the arrows, a lot of kids will write just CWA, CWA. You can put the things in every single box if you want. It doesn't matter to me. Okay, next we move over, and this is just for the reactivities of metals. So we'll do these. Don't cross them out, but we don't care about those for right now. So the next thing we have is aluminum was AO. AO means acid only. That means that anything that has AO will not react with hot or cold water. It will only react with acid. All right, and then the rest is NR. And I'm not going to scroll up, but NR just means that these do not react really to anything in our class. So no hot water, no cold water, no acid. So make sure that you have those labeled on your periodic table. All right, then you will also notice these arrows. So they point down and to the left. Put those arrows on, and that's showing you the reactivity trend for metals. So down here is very reactive because it's to the left and it's at the bottom. And up here would be not very reactive because it's up and to the right. So make sure you have those arrows as well. Okay, then while we're here, we learned in yesterday's lab, and I know I wasn't here, so maybe you didn't learn it as well, but for non-metals, fluorine was more reactive than anything in its family. So for the non-metals, you're going to put arrows that point up and arrows that point over. All right, now we do not include family 8 whenever we talk about reactivity, because family 8 doesn't actually react. So make sure you have both those sets of arrows, and remember the separator between metals and non-metals are these, is this staircase. So if it's on the left side of the staircase, it will follow the lower and lefter, which I know is terrible, but I don't care. If it's on the right side, it will follow the trend of higher and righter as the more reactive, excluding family 8. Okay, make sure you have that.